number theory result here that's kind of neat. It says that if the exponent of 2 is never a power of 2, then that 2 raised to that exponent plus 1 is not a prime number. Now, that follows, it's a fairly quick little proof here. It says if k is never a power of 2, k must have a prime divisor, and that makes sense. 2 is the only even prime. Every other prime is an odd number, right? So that means that k has to equal to a times b, where a and b are integers, but a is odd, which is more important than it being prime actually in this proof. Now the claim that under these conditions, this is what I'm claiming. This attempts to establish that. I'm trying to establish that 2 to the b plus 1, the same b that we get right up here, is a factor, a proper divisor of 2k plus 1 is what I'm trying to show. Okay, now this is certainly a clear statement right here. Any number is congruent to itself. In other words, 2 to the b plus 1 divides 2 to the b plus 1, and this is just a restatement of that in congruence arithmetic. Now, another way to write this that turns out to be useful is to treat it like an equality, and you get that 2 to the b is congruent to -1. Now, I'll omit the moduli just for the sake of time here, but the moduli is understood to be 2 to the b plus 1, which is going to be the divisor that we're seeking right up here. Okay, now right down here you can see what happened. 2 to the b is congruent to -1 by subtracting 1 from both sides of this congruence. Okay, and so if you rock along here, k is equal to ab. You can this right here is laws of exponents. 2 to the b is congruent to -1, so that's where this -1 comes from right here. Okay, now a is odd, folks. Remember, a is odd. A is odd. You can see right here, a is odd, and that's a logical consequence of this not being true here. Now, so another way to rewrite this congruence, again, you can treat these just like equalities in many cases. You can write down 2 to the k is congruent to 1 when you add 1 to both sides. So it's congruent to 1. I'm sorry. If you add it to both sides, this will be 2 to the k plus 1 right here. 2 to the k plus 1. Okay. Is congruent to 0. Okay, modulo this, but that means that 2 to the b plus 1 divides 2 to the k plus 1, which is what we're trying to prove right here. Okay, now it does even more for us. Since k a is greater than, since AB is greater than B, we get that 1, let me just write it right up here, we get that 1, let me just write it, 1 1 is less than 2 to the b plus 1. Is less than 2 to the k plus 1. Okay. Now, that means, coupled with the fact that it's a divisor, that means that 2 to the k plus 1 is not prime. So we've proved what we set out to prove. So anyway, y'all, I hope that made sense. Hope you enjoyed it. It has an interesting contrapositive. It says that if 2 to the k plus 1 is prime, then k would have to be a power of 2.